I'll start with unit number 1, which is introduction. And what we are going to hopefully, when we end this unit, you should be able to know a few things, and I hope you have printed and you have in front of you the concept questions from unit number 1, and it also gives you a good outline on what you are expected to learn. So basic things that you need to learn is what fluid mechanics means, what is fluid, difference between gas and liquid, and the key thing is the concept of continuum in fluid mechanics. And we will talk generally about different units so that it's kind of a refresher for you, so you know the units of all the basic like force, energy, and power, so you know the difference between these units and how to use them. And the main concept questions that you would be responsible for, and these may appear in the test as well, will be difference between solid and fluid from fluid mechanics point of view, and the concept of continuum. So let's start. So for this unit, we don't have any numerical problems. These are just concepts and understanding the basics of fluid mechanics. So let's start with what is fluid mechanics. So if you were to define fluid mechanics, you would say, well, it is a study of fluid, obviously, but we think of it in two ways. We say, well, fluid mechanics is a study of fluids at rest and in motion. So the first half of this course will be, we are going to look at fluids at rest, and then hopefully the next part of it will be all fluids moving in motion, and we will see what physical laws govern those motion. So the key now is, what is fluid? If you look at fluid, and in general, if you can say, well, fluids can have two different things. You have gases and liquids. Remember the general definition of a matter. Matter can be, we learned it in high school, matter can be solid and liquid and gas. So the fluid is that part of matter that deals with liquid and gases. Obviously, there is something else called plasma, which we never deal with, at least in engineering, civil engineering field. We never look in plasma, not now, maybe in future, but we don't need to deal with plasma. So fluids, we only say, well, it's can have two different components. You can talk about gas as well as liquids. So now, what's the definition? The first concept, I'm going to come to this topic, and we will look at the difference between solid and fluid. And that's the first concept question that I'm going to deal with. So I'm going to say concept number 1 will be main difference between solid and fluids. So the main difference is that when we talk about fluid cannot withstand shear. So when we say, well, fluid deforms permanently and continuously and that means flows under the action of shear stress. Whereas solid will deform but will never flow under the action of shear stress. So we can write solid will deform but not flow under the action of shear stress. And remember, if it's elastic solids, then it may deform when you remove the shear, it will come back, whereas fluid will deform permanently and continuously. So that's the main difference between the two. There is also difference between solid. Another difference that you can write in under concept 1 is that in case of fluids, rather let's look at first in case of solids, because I think we are more familiar with solids. We know that stress is directly proportional to strain, which is kind of called Hooke's law. And in case of fluids, stress is directly proportional to rate of strain. So there is a difference between the two, and we will come back to this hopefully in Unit 2, what is a strain and how shear is directly proportional to rate of strain. But now, just for now, this is just a definition, which is a direct result of basically the first part, which tells you that the fluid will deform continuously and permanently under the action of shear. So rate of strain becomes more important than strain itself, because it will deform continuously. So the higher the shear, the higher the rate of strain, the more it will deform and rapid that deformation will be. So that's the key thing. Now when we say fluids will deform continuously and permanently under the action of shear, but there is always an exception to every rule. And you may have seen this, that if I take a drop of water and carefully place on a solid surface, that water drop holds its shape and it does not flow, although there is a gravity force acting on it. But it will not flow. Why? Because of surface tension. So the key thing here is surface tension will hold the liquid together against the shear which is applied by gravity. So even if you take a water bottle and you pour that water slowly out of the bottle, you will see that as the water falls on the floor, it will spread. But there comes a point, if you stop pouring, it will come a point that the water will stop flowing and it will hold, there will be a maximum limit to it where how far it can flow. Now if you look at the end carefully, you can see a concave end of it. And the reason, because the surface tension is again taking hold of that flow. It's not allowing it to flow into a thin sheet. So it still has some thickness. So shear makes the fluid flow, but surface tension effects, if it is too thin, will come into picture. But most of the time in civil engineering, we really, surface tension we don't consider unless the depth is very small. So this is all about surface tension. This is all about shear stress. Now, difference between